This is Algebra 1, Unit 10, Lesson 3 on measures of central tendency. Now, in our day-to-day activities, we deal with many problems that involve related items of numerical information that is called data. Statistics is the study of sets of such numerical data. When we gather numerical data, besides displaying it, we often want to know a single number that is representative of the data as a whole. So we want to be able to make a conclusion using a single number about our data. We call these types of numbers measures of central tendency. So the two most common measures of central tendency are called the mean. The mean is the average, which you may have learned back in 7th or 8th grade. And the median is the middle number, like we talked about when we did the quartiles. So the median is the middle, the mean is the average. So what we use those values are to try to make a conclusion about a set of data. Okay, so let's take a look at our first problem here. We have a survey was taken amongst 12 people on the number of passwords they currently have to remember. The results in ascending order are shown below. State the median number of passwords and the mean number of passwords to the nearest tenth. Okay, so we need to figure out the median and we need to figure out the mean. Okay, so I'm going to show you how to do this on the calculator and on Desmos. You already actually know how to do this on the calculator, but we'll look at it both on Desmos, but let's look at them both. Okay, so here is, let me go back here so we know where we got this from. All right, so to get to your list, it's stat, edit, and then you have L1 here, and it should be all cleared out. So all you have to do is enter your data. So 0, 1, 1, 1, and then 2 2s, and then 4 3s, and a 4 and a 6. Okay, all right, now to get the mean and the median, you have to go to various statistics. So that's stat, go over to calc, number 1, various statistics, and we're using list 1, so we want to go down here to calculate and press enter. All right, so if we look, we know where median is. We did median before. Median down here is 2.5. So we can immediately put down the median. The median is going to be 2.5. All right, now the mean, we actually is already on that list too. The mean has its own symbol. The symbol for mean is the X with a bar over the top of it. It's called X bar. That gives you the mean. If you look at your calculator and scroll up to the very top, you can see the mean is the first number right here. X bar right here is the mean. So the mean rounded to the nearest tenth is going to be 2.4. All right, let me write that down. Okay, now if you're doing this on Desmos, let me put Desmos up here. Here's Desmos. I already put in the list. All right, so notice here, remember you with the list, you put A equals, you put brackets, and then each of the numbers in the data set with commas going here, and there's 12 elements in the set. All right, so your mean, what you have to do is go down here, go to functions. All right, make sure you're looking at the top where it says stats. All right, and then we want the median, which is this one. Whoops, I don't want that one right there. Sorry about that, I have to be in the next column. There we go, I gotta go down here. All right, so we're going to use this list. Let me do that again. Median of A, and you can see is 2.5. And on that same page, functions, mean, keep going on the wrong one again. All right, and then go down here, functions, mean of A is 2.4, and I still get the same answer. All right, so you can do it either on Desmos or the calculator. All right, so what we're looking at is the middle of the data. So the mean and the median are actually pretty close. So this is 2.5 and 2.4. So the middle of the data is probably going to be about the same value when you do this. So your middle of your data is going to fall somewhere right in here. So a typical number for that data is going to be around either 2.4 or 2.5. So how do you decide which one we're going to look at? All right, let's take a look at the second problem. Students in Mr. Okafor's algebra class were trying to determine if people speed along a certain section of roadway. They collected a speed of 20 vehicles as displayed in the table below. Okay, so find the mean and the median for this data set. All right, so we need to find the mean, which is X bar, and we need to find the median, which is the middle number. Okay, so what we need to do is figure out the data for this. Now notice this is what's called a frequency table. All right, so instead of, what we have to do for this is we have to know how many of each of these speeds exist. So there's 129, there's 233s, there's 434s. Now you can enter this table in your calculator, or you can enter each one individually. I'm going to have you do it individually just for our purposes today. So when you do this on your calculator, when you enter this, all right, you want to go to Stat, Edit. I'm going to clear this out. All right, up, enter, clear, and enter. And then you want to enter your speeds. All right, so there was 129, and there was 233s. Oops, 33, not 3. Okay, and then 434s. And 535s. There's 535s, 336s. Uh, 238s. 239s. And a 54. All right, so there's our 20 speeds that we have. Okay, now you can also do this on decimals using your A. I did it right here. I put the same numbers in. It's A equals bracket, and then each of the numbers in the list. And notice there's 20 elements in this list as well. Okay, now for the mean and the median, we have to do Stat, Calc, number 1 var stats, enter. We're using list 1. And then go down to calculate. All right, so the mean is the X bar, which is 36.1, and the median is 35. So going back to here, the mean is going to be 36.1, and this is going to be 35. Now this is in miles per hour, is the speed. So the mean is 36.1 miles per hour, and the median is 35 miles per hour. All right, so there's the mean and the median of the data set. Now, let's take a look at the information that we have here. All right, if you do this on decimals as well. All right, so for decimals, it would be, next one, the mean of A is 36.1. And back to functions here, the median of A is 35. So we get the same answer. Okay, now what we want to know is, the speed limit along this part of the highway is 35 miles per hour. Based on your results from Part A, is it fair to make the conclusion that the average driver does speed on this roadway? Okay, now remember the mean is the average speed of all of this data set, and the median is the middle number. All right, now if I look at the median, which is 35, which would be right here. Okay, there's the median, and we have 35 or less would be not speeding. So the median would be here. Okay, so this is a total of 1, 2, 3, 7. This is going to be 12 of them are going less than 35. How many are in the data set? It would be 20 in the data set. So that's more than half of them are going 35 or less. So, based on your results part A, is it fair to make the conclusion the average driver does speed? This would be no. Okay? 12 out of 20 are going 35 or less, which is more than half. Okay, so that means they are not speeding. All right, now how come then the mean 36.1 looks like they are speeding? All right, that is the problem with that because of the average is made up of all the numbers added together. What would make the mean be more than the speed limit? Well, let's take a look at the numbers here. These are all kind of close together except for this one right here. So the mean is above 35 because of the one person driving 54. So what that does is it throws off the mean or the average speed. So this is called an outlier. We'll talk more about that in just a few minutes. So that is an outlier. This speed of 54 makes the mean bigger. So that's not a good measure of central tendency because it throws off thing. We can't say that the average person driving is going 36.1 because of this 54. It throws it off. But we could say on this, based on this data, that most of these people aren't speeding because the median number is 35 miles per hour, and at least 12 people are going that or less, so they're not speeding. So that's most of the data, or the majority of the data, most of the data. Okay, so that's the mean and the median making that. So you have to be aware of things called outliers that can affect your list. All right, when conducting a statistical study, it is not always possible to obtain information about every person or situation to which the study applies. Unlike a census, in which every person is counting, like we are doing this year with the population of the United States, some studies use only a sample or portion of the items being investigated. Whenever a sample is taken, it is vital that it be fair. In other words, the sample reflects the overall population. All right, so let's look at exercise 3 for a second. To determine which television programs are the most popular in a large city, a poll is conducted by selecting a sample of people at random and interviewing them. Outside which of the following locations would the interviewer be most likely to find a fair sample? So why would they be appropriate or not? So which one would be the most likely fair sample? I'm thinking the grocery store. Yeah, it would be the grocery store because everybody uses the grocery store. Everybody has to go to the grocery store to eat. All right, now a baseball stadium, what would they watch? And people that go to the baseball stadium would probably watch sports on TV. So you would have more people that watch sports. A concert hall, that would be probably people who like music. All right, and a comedy club is people that like comedy, so they'd be more likely to watch funny shows on television. All right, but a grocery store would show that everybody. So this shows that it would be a fair sample because everybody with various ideas would have to go to the grocery store eventually. All right, Trong is trying to determine the average height of high school male students. Because he's on the basketball team, he uses the heights of the 14 players in the team, which are given below in inches. Calculate the mean and median for this data set. Round any non-integer answers to the nearest 10. So basically, anything's not a whole number, round to the nearest 10. All right, I already put the data in my calculator, so let's just do this quickly. Stat, calc, var stats, list 1, go down to calculate, enter. The mean is 74.6, and the median is 74.5. Okay, so let me write that down. Oops. All right, the mean is 74.6, and the median is 74.5. All right, now, is the data set above a fair sample to use to determine the average height of high school male students? Well, actually, no. What do we know about basketball players? Basketball players tend to be taller. Players tend to be tall. So, taller than the average high school student. Male high school student. So, would this be a fair sample to say the average student in the school? No, it wouldn't, because basketball players are taller. So that's not a fair sample. So if he'd gone somewhere else, maybe to the cafeteria or something, where everybody eats, then it would probably be more of a fair sample. Okay, data sets can have members that are far away from all the rest of the data set. These elements are called outliers, which we talked about before, which can result in a mean that does not represent the true average of the data set. All right, in Mr. Petrovic's advanced calculus course, 8 students recently took a test. Their grades were as follows. So I already did this for you. So the mean in this set is going to be 81.75, and the median is going to be 86. So what score is an outlier in this data set? Which one kind of jumps out at you? Well, it'll probably be the 45. So that's the outlier. So which one is better? The average student did. It would have to be the median because the mean is affected by this outlier.